So good afternoon, everyone, and welcome to our last session today. And it kind of dovetails really well with the last one. So if you're on the last one, hopefully we'll carry on the conversation here. But this time we're looking really at panel discussion from the manufacturers and what they can bring to the table, perhaps some of the solutions that they've got, innovations that can help us meet our net zero ambitions on house building. And delighted that another Nathan is going to present this one, Nathan Gambling. Hi, how are you doing?
I'm very well, Nathan. How are you?
Very well, thank you. As people no doubt see, you're the host of, is it Beta Talk, Renewable Energy Podcast? And I understand you won an award recently, so I'm sure hopefully you can tell us about that. But also you're a lecturer in heating and low carbon speaker as well. So welcome, and I'm going to hand over to you.
Thank you very much. And I'd like to welcome all my guests. I've just been watching Kunle and Michael on the other session, so you may be joining us to watch them again. So I'll go to Max first. Max, could you introduce yourself and tell us who you represent, what you do?
Hi Nathan, good afternoon. Good afternoon, everyone. So my name's Max Halliwell. I'm currently Communications Manager at Mitsubishi Electric. We manufacture air source heat pumps. I'm also the Vice Chairman of the UK's Heat Pump Association. So very much got a focus on air to water heat pumps.
And Ian, you're involved in MVHR and things like this, aren't you, your air movement?
Yeah. So hi, everyone. So my role is head of UK specification at Airflow Developments. We manufacture anything from your sort of small bathroom extract fans right up to medium to large heat recovery units for domestic and commercial applications. My main role is to oversee the specification team and everyone at Airflow, covering all across the country, whether it be domestic, social housing, house builders, and the M&E side as well.
Thank you. And Michael, you're from Studio Agno. Have I got that right?
Yes. Yep. I'm an architect and director of Studio Agno Architects. So we've, you might have seen in the last presentation, we've been working for the last couple of years on a very sort of a progressive design for carbon positive zero waste development, as somewhat of a sort of pioneer project for some of our new work and future developments.
Where is that again?
That's in Walthamstow. It's a brownfield site. It's got all the making. Well, hopefully it'll be a very real site, but it's certainly at the moment, it's a lot of research and development.
And Kunle, you wear many hats. Most people will know you from TV. Can you tell the audience what you do, please?
Yeah, so I'm Kunle Barker. I am COO of Melts Property, which is a boutique property development company. And we do residential schemes. We've got one in Gloucester at the moment, and we're using ground source heating there. We're looking at we're about to hopefully get planning on a hotel in central London. Well, not central, actually, sort of Clapham Roadway, just near Oval, 146 room hotel. And we literally, for the last week, my biggest task has been looking at what sustainable tech we should be using. So should we be using ground source or air source? So I do that, and also I have a role as non-exec director at Studio Agno, so I'm familiar with Michael's work as well.
Well, thank you all for that. And Nathan said I can introduce myself. So I'm Nathan Gambling. I host the Beta Talk podcast. I've kind of grown up in the heating industry. My grandfather was venerated throughout Europe. He kind of brought oil technology to this country with the pressure jet burner, and because central heating is actually quite a relatively new industry, so I've been involved in it all my life. And I've just run a British Renewable Energy Awards for helping disseminate the voice of the heating engineer, because heating, believe it or not, is very, very complex. And I think we're all now starting to realise that. As my friend says, putting a ball on the wall is a get out of education free card. Anyone can kind of do it. But when it comes to hydronics and thermodynamics, it does tend to then get quite complicated. And one of the hard or the biggest challenges you all face is knowing who good, competent engineers are. because my other soundbite is in the UK, we teach people to be qualified rather than teaching them to be competent. And there's a huge difference. So Max, I'm going to come over to you first. I know you, don't I? And also know Phil at the Heat Pump Association. So for people building houses, what would you suggest that they heat them with?
Well, we're naturally going to say air source heat pumps. The government and the CCC are very much on our road to net zero. With the UK grid set to be completely net zero by 2035, it makes sense to attach anything to that grid for heating our homes, because home heating seems to be the hidden carbon, I think. We look at these high profile things, flights, driving SUVs, etc. But believe it or not, the way we heat our homes has probably got one of the biggest impacts on our carbon footprint. So with the government's 10-point plan, the banning of gas in new build in 2025, for me, the most natural solution is to go across to heat pumps, because heat pumps will make the best use of that energy that we're providing through the grid. Our grid is getting cleaner and cleaner every month. The wind turbine output now is increasingly massively, our PV farms. And as we move across to nuclear power stations, where our carbon footprint of our grid is going to also, it makes sense to make the transition to this electric economy using heat pumps.
Now, I suppose a question anyone involved in development would want to ask is what is the cost comparison to putting these in to compare to what the traditional boiler?
That's a good question. The good news is with new build, it's a much simpler proposition. With retrofit, we have all the questions about, are my emitters going to be suitable, taking out the old gas boiler. But when you're starting from scratch, the on cost of the emitters is virtually negligible, because you're starting from scratch anyway. Radiators are relatively cheap. And if you go from, say, a single panel to a double panel, or if you just make the area slightly bigger, that's a small on cost. But overall, we think if you compared it to a fossil fuel system, such as a gas or oil system, you probably on average look at on costs of a couple of £1,000 to put the heat pump system in instead of a fossil fuel system. That's from you.
So I want to bring in Ian. Now, obviously, we tend to talk a lot about heat, how we heat our homes, and we're obviously sort of insulating them and making them more airtight and trying to prevent that second law of thermodynamics and equilibrium. One of the things people don't tend to talk about, though, as we make them more airtight, is ventilation. And I think that came into build regs the year I sort of passed out on my apprenticeship, around about 91, 92, I think, ventilation. But that's what you're involved in. How important is ventilation in homes?
Yeah, well, you touched on it there, Nathan. The fact that more and more of the modern buildings are so airtight, you've got very little air coming in or out. And you get some homes even built to passive house standards now. But the more airtight we make these homes and buildings, the more crucial it is to have the right amount of ventilation in there. And if for example they're not open the windows regularly, then they do need a form of mechanical ventilation in place to provide that. And when you touched on the heating side of things as well, obviously if they have a heat recovery system in there, it's going to recover their heat, and the more efficient that heat recovery system is, the more heat is saved and recovered. For example, back a long time ago now, when sort of heat recovery systems were only recovering maybe 50% of the heat, nowadays they recover up towards 89, 90, 90% heat recovery. So we're losing very, very little air very little heat when we have these heat recovery systems in place. As I say, like the air in the room in the building was around 21 degrees. If you have a heat recovery system in there and it is around 90-95% efficient, the air that it's bringing back in is still going to be around 18-19 degrees. And then you can just top it up with additional heating. So whether there is heating already in the building or underfloor heating radiators, or whether you put that additional heater on the ventilation system.
Are you seeing? It's a horrible topic to bring up in some ways, but COVID, did that sort of engender more interest? I mean, I know my cousin's involved in things like thermal wheels and heat recovery, and obviously a lot of the his clients are worried about sort of some sort of filtration system or some sort of system within MVHR that can kill viruses. Has that engendered more interest in sort of the products that you sort of sell?
Yes, absolutely. Yeah, I mean, we're seeing a lot on the news lately. You know, so there's more and more talk about ventilation, indoor air, and everything. I know there's still recommendations just to open the windows, but you know, in the wintertime, it just doesn't happen, does it? So everyone wants to keep the hot air in. But yeah, on the filtration side, obviously these heat recovery units have standard filtration on them anyway, but if you want to be able to guarantee or reduce the risk, shall we say, of virus particles going around the building, then there is technologies that can be used with the ventilation system. So things like UVC filters, things like ion generators. These are new technologies that are coming in now, that can be installed within the ventilation system with heat recovery units or in the duct, and these technologies help destroy the virus cells.
So when I come to you, Michael, what sort of technologies, heating and ventilation technologies, have you been using in your sort of developments?
Certainly air source heat pumps are by far the sort of thing taking over from boilers, you know, and that's the big shift, I think, and that's obviously led by the building regs and the requirements, and that appears to be the successor, I think, to the old school boiler in the hidden cupboard, you know. You know, we talk about ground source and other ways, but that's primarily the one most developers are going for.
And Kunle, have you sort of come across this sort of technology, or are you using it, or?
Yeah, absolutely. So we have a development 17 years in Gloucestershire, and we have installed a community ground source array. We looked at air source as well. I think there was no particular reason other than, I think for us, because it was a new build job, it was relatively straightforward to do ground source. But what I'm quite excited about air source heating is its application in retrofitting, where you know ground source doesn't. So one of the other things that I do is I'm a spokesperson for the government's Green Homes grant, and we're doing a lot of work trying to convince or help people understand that, you know, an air source heat pump is something that, you know, I live in northwest London and, you know, a terraced house, but you know we could fit one here, whereas, you know, ground source is just not possible. So yeah, that for me is really exciting. It's, you know, it's about horses for courses, I guess, with those things. But we're looking at a hotel development, and we're still discussing whether we would use air source or ground source. And I think it will come back to a pretty simple calculation based on the benefits versus costs, and you know the other disruptions and stuff that, you know, air source is a much easier thing for us to fit rather than ground source. So, but yeah, it's all very exciting, I think.
Now, Max, you and I have been in the industry a long time, and my cousin's been installing your product for way longer than you've been involved with Mitsubishi. 40 years, I should imagine my cousin's been. So many commercial buildings, pubs, clubs, restaurants, offices, many of them, millions of heat pumps already installed that heat and cool these buildings. And yet we still kind of, don't we find this sort of discourse where a lot of people think a heat pump can't actually heat a building. And I know people that say this, and they'll type on their social media, they'll never work. And if they were to look up, that's what they're actually being heated with. Have you seen more sort of uptake in the domestic sector with your product?
Yeah, so there's two sides to this. You've got the stick, carrot, or three sides, and the social acceptability. I think once society realizes that heat pumps are a simple technology, and understand them, that essentially it's the same as their fridge, but in reverse, and the technology's been around for many decades. I mean, look at Scandinavia, the biggest user of heat pumps in Europe, and it's the coldest area. So people do have fears because it's new, I don't understand how it works. But the uptake now is just phenomenal. The interest we're having over the last year. The UK heat pump market last year was around 35,000 units. You compare that to the 1.6 million gas boilers and 70,000 oil boilers, we're still scratching the surface. But this year, there was a survey done, the Heat Pump Association made a press release a couple of weeks ago that the main manufacturers supplying into the UK expect to supply some 70,000 units into the UK market this year. And I've got a publication somewhere. In fact, yeah, this is a great publication. It's by the Heat Pump Association, and it's basically delivering net zero, and it's a roadmap for the role of heat pumps. And we took some information from the Committee for Climate Change, who show the projection of the required uptake of heat pumps to meet the government's aspirations. And I think Boris recently said 2028, 600,000 heat pumps per year. Now, the interest is there, the uptake is there, manufacturers are gearing up, but we've got a couple of barriers as far as I can see it. So the first barrier, which is be keen to your heart, Nathan, is that the installer base at the moment is tiny, and to upskill this installer base is going to be critical, but it is quite a simple thing to do. And we're working at the Heat Pump Association to provide courses to allow people to make the switch so the technology can be installed in a competent way. So that's the first barrier for mass market uptake. And the second one is consumer acceptability. Once the word is out, it's a bit like PV. PV suddenly became a success overnight because people could see it, they understood it, people were talking about it. So, oh, what's that? It generates electricity. And I think once we've got maybe, I don't know, 1 million so heat pumps installed in the UK, then I think we're going to start to get that momentum, and that will cascade down from the new build regulations, the Future Homes consultation, and also the continued government support with the Green Homes Grant and the Clean Heat Grant, which will replace the renewable heat incentive next year. So I think the time for the heat pump has certainly arrived in the UK.
I'm just going to sort of talk about policy. I know when I talk to a lot of the heating engineers, they don't tend to sort of be involved with policy. And as we all know, there's all sorts of policy talk, isn't there, in this industry? Yeah. And Kunle, what is going on at the moment, sort of with policy? And is there anything that's on the agenda that's going to help push or drive things forward?
As Max said, I mean, there's an incentive scheme which is due to end, I think, for bigger schemes anyway, which is ending, I think, any application needs to be in by the end of this month, and it has to be commissioned by next year. But there's a new scheme which is going through the government at the moment, which is good. I mean, little concern. I mean, the Green Home Grants is great on a kind of, on a micro level to help solve the problem. There's a huge education gap there, though. People just do not know what these things are. They've got no idea. And interesting, I was working with a company with OVO, and they're trying to install like 100 of these. They're doing a case of getting 100 air source heat pumps into people's homes. And I think, as Max said, it's one of those things like, you just sort of see it. You go to, that's just the way humans work. We go to someone's house and see it. Oh, what's that? And, or someone else tells us that, we see it on the street, and so we're getting there. People are, we're going to get there when people realize the benefits, not only, I guess, in terms of costs, in terms of running, but also in terms of the environment. I mean, I think one of the gaps of knowledge there as well is there's this perception, I think, that because it uses electricity, and electricity per kilowatt hour is 4 times or something more expensive than gas, that it is actually it could be more expensive to run. I'm not sure that is the case in most circumstances, but I think there's a lot of the government. It's okay to have something like the Green Homes Grant, but it doesn't really work unless there is some kind of education strategy behind that to go alongside it to educate people.
Yeah.
Agree with that. Can I just pick up on one point, Nathan, before we move on? That's a good point, Nathan, about the run costs. You're absolutely right. So one of the barriers, for example, is the cost of electricity versus the cost of gas. We've got a massively subsidised gas network, and electricity is penalised. So, but there are solutions. You mentioned OVO Energy. We're working with them on that project you've mentioned.
Oh, okay.
It's the electrification of heat project, and we're one of their suppliers. And one of the things they're very interested in is the demand side response, because if we can get demand side response into heat pump technology, which we've got the ability to respond to a smart grid, and then if you can then use your your cylinder as a thermal store, or introduce a buffer, etc., and be more flexible of when your power company supply you electricity. OVO, we're talking about figures. If you can drive that cost down to 10 pence per kilowatt hour by being flexible when you heat, you then suddenly have not only a carbon competitive technology, but also financially attractive to the individual.
Yeah, and this is where things like the agile, and I know that was spoke in the session that Kunle hosted. I think agile tariffs like Octopus Energy, when people can actually heat up things like their buffer stores, and that, when it's during the night. I mean, I know we're all old enough to sort of remember Economy 7, but agile tariff now it buys electricity in half-hour increments, and every one of them increments is a different price. And it's all quite clever tech beyond me. I mean, I'm just used to cleaning out toilets and putting in pipes, but this whole thing of electricity is and the way it's going to be distributed is quite interesting. Coming back to you, Ian, and ventilation. What is the standard at the moment? So let's say I wanted to build a house. I was a developer. What are we finding developers are building to minimum standards when it comes to ventilation? I mean, you and I know how incredibly important. I've got asthma, and there has been quite a famous asthma case death, and I think a charity was founded, wasn't it, off the back of that? Are you finding developers really sort of take on board the importance of ventilation, or are they just building to minimum standards?
It's a difficult one. I mean, it always, like everything, it always comes down to costs, doesn't it? So, if in a lot of buildings, yes, I would say it's down to minimum standards at the moment, and it's just like I think there's still a lot of education that has to be done on the importance of ventilation, because I mean, to some people it's just a fan that just extracts, but to others it is a bit more important than that. So I mean, we are seeing now a few changes with some of the house builders that we work with, going from your standard intermittent fan, moving more towards DMEV, centralized extract, which is continuously running, because continuously running fans are better for homes, especially if the intermittent fan never gets turned on, because sometimes you get complaints, the fan's noisy, I don't want to turn it on in case it costs me money. But to run a fan in a year, some of these fans it could run for a year and cost less than £1 to run. Are they then putting a price then on their health? Because if you don't have any ventilation in there, and the building is really airtight, and you don't open the windows, then you're breathing in toxic air.
Now, you mentioned noise. Now, as we've built homes that more insulated, noise levels were factored into ventilation, weren't they? That they had to sort of come down, because if we live in sort of homes where we can't hear the outside world so much, anything that's making a noise inside, we tend to sort of pick up on more now, don't we? So there was rules and regulations that came in to sort of drop that to a certain decibel, wasn't it?
Yes, correct. And we're all for those regulations, because we're, as one of the leader manufacturers, we do have the fans with the quiet air, with the quiet mark on them. So, they do meet those standards of noise levels, so much so that you then get complaints, the fan's not working, I can't hear it. So then it's almost the other way around. But we do have those quiet running fans available.
And Max, that's something in our industry, isn't it? In the heat pumps, I know people that are potentially interested in heat pumps, but they're worried about noise. They think they might be waking up their neighbours. I mean, do you want to talk about that?
Yeah, so it's a very good point, actually, because the last thing you want to do is introduce something into a neighbourhood that's going to cause a disturbance, and when someone latches onto a noise they can hear, that's all they can hear. Fortunately, there's decent legislation that protects the general public. Under planning law and under the microgeneration scheme standards, if you have a heat pump installed, either under the MCS standard, microgeneration certification scheme, or if you put a heat pump under planning law, your heat pump must meet certain quite strict sound criteria. And that's essentially a measurement from your neighbour's nearest facade to ensure that the sound that's produced from your heat pump doesn't cause a nuisance. Now, we actually developed, we came up with the name Ultra Quiet Ecodan. Ecodan's our brand name. Sorry about the sales pitch here, but we looked at this in the UK because the UK is a very densely populated area with huge urban areas, etc. And if we want mass market uptake of heat pumps, we have to ensure that a heat pump could be placed flexibly around the building in its most suitable place while not having an impact on the neighbours. So we think sound performance for the uptake of heat pumps is absolutely critical. So it is important. And gone are the days of there were some quite noisy manufacturers, but that's a long time ago now. The majority of heat pump manufacturers now have very, very quiet running machines.
I'm going to bring in a couple of questions that we're getting from the audience, and I'm going to ask who should I ask this one? I might ask Kunle this one. So basically, someone's asked, what are the panel's views on other decarbonised heating systems that are as efficient, especially when connected to PV and when well-insulated properties? So they haven't actually suggested what they think are as efficient, but I mean, have you got any other heating technologies that you like or you're looking into, Kunle?
I looked at something called sun amps. I don't know if anybody's heard of those.
Yeah, I know Andrew Bissell quite well.
Right, yeah, it was extraordinary what they can do, and they work really well in very well insulated homes, I think. They're basically, this is probably completely the wrong way to describe them, it's how I describe them to people. They are basically those little warmers that you get when you go skiing. You press a button and they go hard, they turn hot, but they work kind of reverse, and then you normally put them in hot water to make them go into liquid again, but with the sun lamps, they run electricity through them and they go back to the original state. But I think, just because they use those in an episode of Grand Designs, and I wrote an article about it, and then did a bit of research.
PCM, phase change material. Yeah, they're
I think that's quite interesting. Other than, I mean, we looked at ground source, air source.
Was the ground source you used, was that an ambient loop? I'm going to mention a manufacturer. Was that Kenza?
It was Kenza. Yeah.
So that would have been an ambient loop. Yeah, very good. Shoe boxes. Yeah.
Yeah. So it's exactly. So there's shoe boxes in each unit instead of a boiler, and it was So I think again, all of these solutions are all it's horses for courses, and people just got to figure out which one suits them best for whatever they're doing. Some of them only work best, like the sun amp is very good it was in a passive house actually, the sun amp, and it worked really well, but it wouldn't necessarily work very well in a leaky Victorian terraced house. So.
Michael, have you got anything of these sort of technologies that you've been looking at?
We did a bit of research during the Walthamstow project, and we looked at phase change. We had a particular problem with thermal mass in the building because we were doing a very thin sticks sort of timber frame building with lots of insulation but absolutely no thermal mass. Yeah. And so we had to deal with that, but phase change was an option. And we looked at, and as soon as you said it, I thought, I can't even remember the name of the company, but these wall panels, flat, just white flat panels, and I can't think what they're called.
Matildas.
And they're really just I'm showing
radiant heating.
Yeah, kind of, but and they had it combined with a system of like, you know, your body was sort of detected so that it could ramp up or ramp down, and it was really just about heating the person rather than heating the space, you know. So you'd walk into a room and it would, you know, it would heat, and it's an interesting concept, and it's, you know, as Kunle said, it works when you've got this ultra highly insulated house, passive house, and all you need is the tiniest amount of heat to up it to comfort level. And I think that'll change the way heating is considered, you know.
I'm going to answer this question as well, because one of the things we don't tend to consider, it doesn't get discussed, and I'm known as one of the evangelists in sort of this country for solar thermal. So traditionally, solar thermal systems in the UK, we kind of took half the system from Europe, and we only heat our domestic hot water with it, which is fine in the winter, fine in the summer. In the winter, you're not going to be able to do that to get to the temperatures needed to prevent Legionellas. But curiously enough, people think winter, you can't heat your homes with solar thermal, and in fact you can. So the engineers I use on Beta Talk, one of them's he's up in Scotland at -0 degrees the other day. He had 40 to 60 degrees on his roof, and then he takes that into a buffer system. He hybrids it with a heat pump system, and there's some days all through this winter where he's just been heating completely from the sun. And like I say to people, if you go out in the winter, you can see, and the reason you can see is because it's visible light, and next to visible light on the electromagnetic scale is infrared. Infrared's always there. Yes, different days you're going to get more of it, but solar thermal tubes, which tend to be more better than panels in this country, are excellent at connecting into our heat pump systems. Fantastic, and it's free. It's completely free technology and clean. So that's something we're trying to sort of get talked about a lot more. We seem to have got these two things of hydrogen and electrification at the moment in a big battle. And that's actually another question. It's a contentious one. What's your views on hydrogen, Max?
Oh, well, this is a contentious one. So I'll keep it relatively brief. So at the moment, hydrogen seems to be a bit of I think it's a bit of a red herring in terms of a solution. It's definitely have a part to play in heating, but whereabouts is, I don't think it really fits into the domestic arena. The reason being is if we look at the primary energy use to actually produce hydrogen and the water use of hydrogen, to me it doesn't stack up, because hydrogen split into, you've got green hydrogen, which is obviously produced from renewable electricity, but the amount of renewable electricity that you need to use is sort of like 5 times the amount of electricity that you use for connecting a heat pump and using a heat pump to get the equivalent 1 kilowatt hour of heat. So then if you move over to, I think it's called blue hydrogen, which is like a byproduct of normal industry, very detrimental to the environment. So it's going to have a part to play in some industries, but I think for domestic heating, I'm not convinced it's the right way to go. So just in terms of, if you just look at the primary energy argument, in terms of the UK's base load of electricity we're producing from our renewable grid, I just think that electricity could be used better. And also, I understand that you have to use fresh water to basically generate hydrogen, unless you desalinate the water, which is even more power to do. So I think for heavy industry and some heavy transport, hydrogen is going to have a place, but I don't buy it for domestic heating at all. I've definitely not sat on the fence on that one.
Has anyone else has anyone else got any views?
Oh, I think you have to go with electric. I think it's the only way we can ever get to carbon neutral, you know, to really, any system you use, whether it's air source heat pumps or some new technology, it can all be created, can all be powered by the sun or the wind, and therefore, you know, it's just free energy, isn't it?
Yeah.
Just seeing if we've got any more questions. We've got another question. The comment has been made about health issues. What is the panel's views on infrared heating, as infrared has been proven to be a benefit to certain respiratory conditions and also other health issues? So we kind of touched on infrared, didn't we, just a minute ago? I mean, as a heating engineer, I might sort of put this out. I mean, I know a lot of my sort of top heating engineers, don't tend to like it in a lot of situations. What we are thinking of, though, is there are certain situations where you would have a very, very low temperature heat pump situation, and then when the building becomes occupied, so there's a village hall I know that's hardly ever occupied. They want to go green, so the design is thinking about putting an air source heat pump system in that's on a very, very, very low temperature, just to maintain sort of a healthy temperature for the building. And then when people do occupy it, and no one tends to know when that happens, it could be on a 2-week or a 2-month thing. When they do occupy it, they can either have air to air, which they might do, and also these radiant panels that know where you are. So if you're in a particular bit of it that knows that you're there, and because it radiates heat moves 3 ways, and that's radiation is one of them. And it doesn't heat the fabric; it just kind of heats you. I do know that there seems to be a big drive at the moment for this technology. Obviously, because it's connected to electricity, so it's seen as electricity. Talking about electric, have any of you considered sort of the battery storage sort of systems that are being sort of talked about? That's probably a good question for you, Michael, isn't it?
Yeah, I mean, we're looking at them for our Walthamstow project, and we're looking at the different brands available. You know, the big man in America is leading the way, but there's new batteries every day, and we do to make our scheme work. We've got 18 solar panels on each roof of the house. To make it kind of work in any sense, you need battery. You need to store that for when people need it, and and our mobile phones and everything. So we have basically adopted that idea, and we're just looking now at who's making the best one, who's making the cheapest one, and it's in flux. I think, to be honest, it's such a new technology. One of the interesting things we're looking at, actually, and not on that project, but using your electric car as a storage device. So if you can
that's controversial, that one.
Yeah, if you can time it properly, you can use your car as a storer, feed it back into the house, give it back when it's sun's shining.
Yeah, vehicle to grid. I mean, why would you say vehicle to grid is controversial, Max?
All it is because I remember being in a meeting with this when we were looking at grid lights. It's a great idea in principle, but it's when you actually start talking about the cross industries. In terms of, you imagine you've got your nice German hybrid or full electric car, and then you link that into your home PV system, and then something goes wrong with it, and they say, well, have you been using it for back? Because obviously there's how these batteries perform is all to do with how, I was listening to the Bosch presentation earlier, very, very interesting guy explaining how the way that the load is pulled out these battery cells in terms of performance decrease the life if you do it too quickly or too aggressively. So it's an interesting area. I can completely see how it could be used, but you're going to need a lot of joined up thinking to make it happen, I think.
Yeah, that's a good point.
Go back to Michael.
Oh, sorry.
No, go on.
I was going to say, for me, batteries were the game changer, especially for the residential market, I think, because I think, on some of our bigger schemes, for example, the hotel, we are not going to be able to produce enough electricity to create all the electric demand. So we don't have this problem. But for residential, having putting a battery, hooking a battery up to solar panels it's just a game changer. And we get your air source heat pump now. You can store that now and kind of use that. And on our bigger schemes, actually, we're looking at the potential. I'm just looking at the moment and the potential of setting up effectively battery substations in the basements of some of our bigger buildings, where we can buy in. So either store some, because there will be days where we have surplus electricity in some of our bigger buildings. Store some surplus electricity, buy some in on low tariffs, and then use that to flatten out the peak in our building, but also the potential of selling that back at peak times and we've had some really interesting conversations with people who do that, not with batteries, but just do that with in a more traditional way. But we thought, well, if we had batteries, and how we can link that up with having EV charging stations within our developments, the hotels and big housing developments. So I think it feels to me like batteries are the sort of key that helps to bring it all bring it all together and move us along that kind of sustainability road.
Yeah, and energy storage has always been one of the sort of mysteries of the energy discourse. I mean, and this is why some people will say hydrogen will play a role, because obviously it can store renewable energy. I mean, I don't think it's going to be that suitable to be going down the grid to individual boilers personally, but I think it's going to be a good energy storage medium, and then you can use it to power a power station, for instance, for your heat pumps.
Can I make one more point very quickly about batteries? One of the issues at the moment is they're expensive. So the person who shall remain nameless, you know, those batteries are 5k a pop or something, right? Which is quite expensive. But I know that people like, I think Aston Martin are doing some research in reusing car batteries as household batteries, because obviously when the car battery gets past its use, it's all to do with the discharge rate. But they need a high discharge rate. A house battery doesn't. So the idea would be that they would then reuse the batteries from cars in the household environment, and that will dramatically reduce the cost of domestic batteries. And that will probably take 10 to 15 years to kind of come through between these batteries start depleting enough to use. But I predict that in 10 to 15 years, the cost of batteries will be, you know, much cheaper, makes them much more widely available to people.
Well, you're right. The expert on that in this country is Gareth DJ Harper. You should have a chat with him at the Faraday Institute at Birmingham. He's been on the podcast. Lovely fellow. That's kind of his area. I just wanted to come back to a technology, because you know, mentioned about different technology. Have any of you come across PVT, which is photovoltaic thermal?
Funny enough, I was talking about it today because I've not got the figures back, but in our hotel, I wanted to use it there to try and to try and decrease the hot water usage, which is the biggest usage in a hotel. And obviously the theory is that they make, not only do they make they generate hot water, but by cooling the panels, they make them more efficient as well. I've not got the figures back. I hopefully will have the figures back by Friday as to what the people modeling it will say, but it's a relatively, in fact, there's the guys at Kenza that put me onto it, but it's relatively new. A lot of people I speak to haven't used it, or there's no data, so it's quite difficult to get information on it.
Yeah, they've got a place that's specific, which is one of the Swansea University sort of a living lab type thing. And Naked Energy are the sort of the probably ones you want to speak to. But it cools down. Yeah, like you say, 26% efficient, I think PV panels are. But if you water cool them, it makes them more efficient. And of course, obviously, that water that's just had its heat transferred to it, we can then use in other systems. I want to bring Ian back in. Ian, MVHR, a lot of the sort of the top heating engineers I sort of chat to, they're getting quite excited about MVHR. Now, it's going to be used quite a lot in passive houses, isn't it? And are you sort of involved with the passive house sort of fraternity in this country?
Yeah, absolutely. From what I mentioned briefly earlier, obviously passive houses are very, very airtight, and they have to have a form of mechanical ventilation in place with heat recovery, because there's no air going in or out of the building. But that unit, that MVHR unit, also has to be passive house accredited itself by the Passive House Institute. We are familiar with those projects. We Airflow ourselves work on a number of passive house projects across the country. I mean, it's a high standard to build to, but you know, if they can get there, it's great, and it'll be a really, really, really energy efficient house.
I'll just better read out a question. So Keith Meredith has obviously been listening to us. It says, Nathan, infrared heats the fabric of the building and everything in it, reducing condensation, mold and damage, benefits all round. And I would agree with Keith, but I've also, Keith, been in hundreds of homes, been involved with heating all my life, and we have seen problems as well. And like anything involved with heating, it comes down to design. And unfortunately, like I say, with the combi boiler has given us this sort of I don't want to say wonderful technology, but it's prevented heating engineers from learning anything about hydronics for a start. And we have now got to get back to that, where these systems, they're the most complex system in your home, the heating system. And unfortunately, our industry got devalued. It's one of the reasons I came out of it. I mean, when I've got customers thinking I'm not more valuable than a painter or decorator, and there's nothing wrong with painting and decorating at all, I can't do it. but you know, the amount of knowledge I had to know is immense. It really is. And we got devalued a little bit by rogue trader programs and stuff like that. And there are rogues out there, but there's some fantastic engineers out there as well. And what you'll tend to find is a lot of these engineers now, and the ones I use, we're chatting with each other, working out what the best technologies are for different homes, different occupancy. And there's a saying we use: there's no panacea. So that, you know, it's not always about a particular tech. Sometimes air source heat pumps aren't going to be suitable. Sometimes ground source isn't going to be suitable. There's never a right solution for everything. So we have to look at every property and its occupancy as an individual case, and that is so important, so fundamental. And I'm sure you two gentlemen that are involved in development sort of know that as well, don't you? You have to look at every property as an individual entity, don't you? It's not like this one size fits all at all, is it? You've got the place in Walthamstow, Michael. Anything else that you've got coming up?
Yeah, we're doing both ends of the scale at the moment. We've got a 300 unit scheme in Basildon going for planning at the moment, which is modular. So we're sort of deep in the discussions on how to power that and heat it, and where to put all the solar panels. So we, you know, as you say, every building is unique, really, and you have to use everyone available and every expert available to look at all the different options. You know.
And that's a big problem. It's always, I mean, who do you know who the experts are? That's, you know, qualifications doesn't dictate an expert, experience doesn't dictate an expert. I mean, we go in a lot of big energy centers, plant rooms, some of my sort of really good engineers, and the stuff inside them is just complete nonsense. I mean, you've got boilers in there that shouldn't be in there. You know, if a building only needs 5 boilers in it, but you've got 10 in there, it's a complete waste of energy. And you're finding this a lot in some of our big buildings in the cities. I've got a question here about air source heat pumps or ACs in reverse. Max, you and I would know all about air conditioning. Most air conditioners aren't actually air conditioners, by the way, they're comfort cooling. But I can understand they can be altered to do both. Why don't you offer this as a standard? So the units that I think the gentleman is talking about, are we going to be doing cooling as well as heating, Max?
So it's a good question. So I call it anything to do with air and a heat pump, whether it be air conditioning, that is an air source heat pump, whether it be air to water. So if you look at a multi-split system or a VRF system, you've got the ability to heat and cool. It's a good question. You can do heat recovery, of course, and in Europe they do have. We've gone for air to water as a straight system because we have wet systems here. But when you go into Europe, where they're used to having hotter climates, say in the south, we do manufacture units that can both produce hot water and can actually heat and cool as well via fan coils. So there are systems with one outdoor unit that can provide you with all your hot water and actually do comfort cooling and heating as well. So those products already exist on the market, great efficiencies. And of course, that when you're cooling, that energy normally would just be vented off to the outside. So you're actually doing something with it. You know, you're providing a hot water cylinder. And we have the same systems in the UK with our VRF systems, where big office blocks could be comfort cooling, and then with that waste energy, just transfer it into the water system instead.
Yeah, I think that people are going to start to become a little bit more interested in cooling as well, aren't they, as they get used to sort of heat pump technology. I'm presuming, Ian, you get involved in a little bit in that, do you?
Yeah, we do. Yeah, and we work with Max's company Mitsubishi on occasions as well, because our ventilation units can have heating and cooling coils inside them or in the duct further down the ventilation line, and some of these coils they can work with an external condenser unit. So we do use hot water heaters, electric heaters, chilled water coolers, and we also use DX direct expansion heaters and coolers as well. And the DX is obviously is the more preferred way to go. So when we do offer heating and cooling with the systems, it tends to be the direct expansion coil hooked up to an external condenser. Although that is mainly on the commercial buildings. And it was interesting, Nathan, sorry, I was just picking up on something that Michael said earlier. He was talking about motion sensor technology, or PIR sensors. It just got me thinking, because you were also talking about saving energy. We often now get asked to supply the ventilation units with some sensors, whether that it's usually CO2 sensors, or humidity sensors, sometimes PIR. But the problem is, if you have PIR, whether one person enters the room or 10 people enter the room, the ventilation will be the same rate. Whereas if it's a CO2 sensor, it's varied based on the CO2 levels. So the CO2 levels will differ if there's one person or if there's 10. So the ventilation would increase or decrease depending on those CO2 levels.
I want to pick up on sensors. Obviously, within heating, there are people that have like their phones, and it can tell the phone what sort of temperature they got in their lounge before they get home and stuff like that. Do these sensors for air quality, are they smart? Do they interface with people's things like phones? So you can say, oh, you've got a bit of a CO rise in the home or something.
Yeah, they do exist. Yeah, and that, I mean, we do encourage customers and everyone to use the ventilation systems with a form of CO2 or humidity or PIR, or some form of sensor, because then it's all run automatically, and it does save you energy, because you're only ever then using the right amount of ventilation at one given time. And yes, they can then, so then these sensors would talk back to the unit. The MVHR units have an intelligent control system, and that control system can be accessed via your phone, via tablet, laptop, or whatever. So the ventilation systems, the same as I'm sure air conditioning systems as well, do have that capability now for you to gain access to it remotely.
I suppose we should talk a little bit about refrigerant. Obviously, these heat pumps use refrigerant, don't they, Max? And I know some people will, when they ask me a little bit about heat pumps, they want to know a bit more about refrigerant. So what's the refrigerant Mitzi are currently using?
Well, basically, without getting technical, the names of the refrigerants basically, they all have a global warming potential, and Mitzi are currently using R32 in their heat pumps. They've moved away from 410A. R32 is the current refrigerant, and the next refrigerants probably will go towards maybe propane or similar. But obviously there are hurdles with using such refrigerants. But it's all about using refrigerants with high efficiency and a lower global warming potential. We do actually have CO2 units. CO2 has obviously got its advantages, because you've got a global warming potential of 1. Does come with its challenges, and they're great for CO2 units. Actually, we do a unit which is great for new build, because they're great at doing high volumes of water over a short period of time. You get a really good COP, where the hot water load is greater than the house load itself. So we are moving, I think most manufacturers, including ourselves, are looking to move towards refrigerants. There is a program, as you know, to lower the impact of refrigerants, and moving across from some of the older refrigerants now, which had some of the GWP of 4, 6, 8,000, I think somewhere, and we're now down to, I think it's 1,600 for R32. So R32, it's going.
600 something. 600.
Is it 600? Sorry, I put 1 in front of it by mistake. So, but yeah, so it is going in the right direction, because you can offset, if they're not handled right. You could offset all the good you've done by letting the refrigerant off to the atmosphere. That's why we've got such well-trained engineers in the UK. But yeah, lower GWP refrigerants is what the industry's working towards.
That was interesting. That you've got the, like I say, I think propane's going to become, which is R290. That's going to become quite popular with you manufacturers, isn't it? And then, like you say, your CO2, which they require quite high pressures internally in the machine, don't they? But it's all interesting how the refrigerants have all been changing over the last sort of few decades. going back to Michael, so if I'm just thinking, I wouldn't mind you coming on the podcast to chat about these. There's 9 homes, isn't there? And
Yeah.
and have you got you're kind of monitoring them, seeing how they're working, and
Yeah,
you're going to collect that data and obviously make some sort of informed decisions from that.
absolutely. It's all about. I mean, the whole architecture world, REBA especially, are trying to take it beyond just finishing the project. You know, you don't just finish a building and then let it go. And it's, you guys are obviously, you know, come after us basically and maintain the thing for 30 years. You know, so we need to monitor, especially in those first few years, see how they're being used, see if we can help people use them better. And with all these technologies, we're going to have to educate the people living in them, but they should be, you know, it's about learning for the next one as well, because we're in a period of huge change from building technology, and we have to learn and learn and learn. You know,
our architects are going to give heating engineers more space, because in the UK they give us a kitchen cupboard for a boiler. In Germany they give you a little mini plant room. You know, they realise we want things like buffers or thermal stores and something to put our plant, but we don't get considered. Consider it's the most complex system in the home. We don't even get considered. We've got to try and find a kitchen cupboard somewhere. But do you think architects are going to start to sort of really sort of consider that the heating is and ventilation is a very, very fundamental thing of the home? You know, the movement of air, moisture, and heat is so crucial to a home, isn't it?
Well, it comes down to a very sort of trendy topic right now is well-being, and well-being is massive in homes. You know, and no more than now. You know, sunlight, heating, moisture content in the house. You know, and you know, your ventilation systems, taking out the moisture and the purge ventilation of opening a window. You know, passive house, don't open the window. You know, but we want to open a window because we want to feel air coming through, and you know, we want to keep that warm, but we want to be able to open a window. And so it's, and thermal mass I was mentioning before, about keeping that steady temperature in a house and not just heating it really high when you're awake and when you're out, or you know. So and my belief with the Walthamstow project is, let the sustainability lead the design and we'll follow after, you know.
Well, we're joined back with Nathan, so I'm assuming, Nathan, we're getting to the end.
We are, yeah. It's been a really good session, so thank you, everybody. Lots of questions came through, and I think we probably could do another hour, but so thank you very much, everybody, for coming on. And this was obviously our first net zero house building event, and been really, really good to have a good day of debate and discussion. The conversations can carry on because this platform stays live. All the content, all the sessions will be up live, and people can carry on talking on it as well. So I hope people make the best of it. And you know, if you want to make meetings and things like that, then you can do that through the platform, and you get an email. So hopefully we can keep on the connection. So thank you very much, everybody, and thank you, Nathan, for hosting and everybody's contribution. So yeah, really enjoyed it.
Thank you, everyone.
Thank you.
Cheers. Bye.
Cheers. We'll see you soon.
See you soon. Bye.
All right.